So in this problem we have ourselves a polar, or rather a rectangular equation that happens to graph to a parabola. And we want to write that as a polar equation. So we need to do some substitutions. We know that x equals r times the cosine of theta. And we know that y should equal r times the sine of theta. And we also know, hopefully, that r squared equals x squared plus y squared. So these are your three different types of polar substitutions that you can do. So we have to somehow take this equation and make them into r cosines, or r sines, or r squareds. So that's not too hard to do right away. I notice there's an x here and a y here. So I'm going to replace x with r times the cosine of theta. And I'm going to replace y with r sine of theta. And unfortunately, we can't just stop right there. We have to do all of the grotesque algebra to simplify this. So multiplying this, or rather squaring it, gives r squared cosine squareds. And over here, 5 r sines. So we have an r on one side and an r on the other, so we divide to get rid of those. So that cancels out this r. It only gives us one r over here. That's a good thing. So r times the cosine squared equals 5 sines. And now to get rid of this cosine squared guy, so we divide both sides by cosine squared. So let's do some simplifying over here. This is the sine over the cosine times 1 over the cosine. So I can split apart my cosine squared into the product of two trigs. And sine over cosine is the tangent function. And 1 over cosine is the secant function. So this is the equation of a polar parabola that opens up, the same as the rectangular formula x squared equals 5y.